Let us consider two sets A and B. As you see, the members of A are P and Q, and the members of B are U, V, and W. So the number of members of A is 2, and the number of members of B is 3. The Cartesian product of the two sets A and B is denoted by a cross, B. And each member of a cross, B, is a two-tuple. The first components of the two-tuple is any member of A, and the second member of the two-tuple is any member of B. Therefore the members of a cross, B, are and the number of members of a cross, B, is 6. The Cartesian product of the two sets B and A is denoted by B cross A. And each member of B cross A is a two-tuple. The first components of the two-tuple is any member of B, and the second member of the two-tuple is any member of A. Therefore the members of B cross A are the members of B cross A are different from the members of A cross B. And the number of members of B cross A is 6. The Cartesian product of the two sets A and A is denoted by A cross A. And each member of A cross A is also two-tuple. The first components of the two-tuple is any member of A, and the second member of the two-tuple is also any member of A. Therefore the members of A cross A are and the number of members of A cross A is 4. The Cartesian product of the two sets B and B is denoted by B cross B. And each member of B cross B is also two-tuple. The first components of the two-tuple is any member of B, and the second member of the two-tuple is also any member of B. Therefore the members of B cross B are and the number of members of B cross B is 9. Now consider another set C having members alpha and beta. Then the Cartesian product of the three sets A, B, and C is denoted by A cross B cross C. And each member of A cross B cross C is a three-tuple. The first components of the three-tuple is any member of A, the second member of the three-tuple is any member of B, and the third member of the three-tuple is any member of C. Therefore the members of A cross B cross C are and the number of members of A cross B cross C is 12. The Cartesian product of the three sets A, C, and B is denoted by A cross C cross B. And each member of A cross C cross B is a three-tuple. The first components of the three-tuple is any member of A, the second member of the three-tuple is any member of C, and the third member of the three-tuple is any member of B. Therefore the members of A cross C cross B are and the number of members of A cross C cross B is 12. The Cartesian product of the three sets A, and A is denoted by A cross A. And each member of A cross A is a three-tuple. The first components of the three-tuple is any member of A, the second member of the 3-tuple is any member of A, and the third member of the 3-tuple is any member of A. Therefore the members of across A are. And the number of members of across A is 8. The Cartesian product of the 4 sets A, C. And A is denoted by across C cross A. And each member of across C cross A is a 4-tuple. The first components of the 4-tuple is any member of A, the second member of the 3-tuple is any member of A, the third member of the 3-tuple is any member of C, and the fourth member of the 3-tuple is any member of A. Therefore the members of across C cross A are. And the number of members of across C cross A is 16. In this way, we can take any number finite sets and construct any kind of Cartesian products. Please subscribe this channel and press the bell icon. Thank you for watching this video.